Welcome back to AI Foundation Learning. If you're new here, make sure to subscribe and hit the bell icon to stay updated with our latest AI and machine learning tutorials. Today, we're diving into supervised learning in minutes. Let's get started. Supervised learning is a fundamental concept in machine learning, and it's used in a wide range of applications. But what exactly is supervised learning, and how does it work? Let's break it down. Supervised learning is a type of machine learning where the model is trained on a labeled dataset. This means each training example includes both the input data and the corresponding output label. The goal is for the model to learn to map inputs to outputs so it can predict the output for new unseen data. Here's a simple example to illustrate. Imagine we're training a model to recognize handwritten digits. We provide the model with thousands of images of digits, each labeled with the correct number 0 through 9. The model learns the patterns associated with each digit during training. During training, the model adjusts its parameters to minimize the difference between its predictions and the actual labels. Once trained, the model can predict the label of a new unseen image of a digit. There are two main types of supervised learning: classification and regression. Classification. This is where the output is a category. For example, classifying emails as spam or not spam. Regression. This is where the output is a continuous value. For instance, predicting the price of a house based on its features like size, location, and number of bedrooms. Let's look at some real-life examples to see supervised learning in action. Example 1. Email spam detection. Email services use supervised learning to filter out spam. The model is trained on a data set of emails labeled as spam or not spam. It learns the characteristics of spam emails and can then filter out spam from your inbox. Example 2. Medical diagnosis. In healthcare, supervised learning models can help diagnose diseases. For instance, a model can be trained on medical images labeled as cancer or no cancer. This can assist doctors in identifying cancerous lesions in new images. Example 3. Predicting house prices. Real estate companies use regression models to predict house prices. The model is trained on historical data of house prices and their features. It can then predict the price of a new house based on its features. Supervised learning also plays a crucial role in generative AI, including large language models like GPT-4. These models are trained on vast amounts of text data where the input is a sequence of words and the output is the next word in the sequence. Let's dive deeper into how this works. During training, the model is fed billions of sentences from diverse sources like books, articles, and websites. Each sentence is broken down into smaller parts, and the model learns to predict the next word based on the previous words. This training process is supervised because the model is given the correct next word during training. For example, consider a sentence like, "The cat sat on the..." The model is trained to predict the next word, which in this case could be mat. The model looks at the context provided by the preceding words, "the cat sat on the," and learns the likelihood of the next word being mat versus other possible words. During training, the model processes a massive amount of text, learning complex patterns and relationships between words. It's not just about predicting the next word. The model also learns grammar, facts about the world, and even some reasoning abilities. This is what enables LLMs like GPT-4 to generate coherent and contextually relevant text. But how does this supervised learning process work in practice? Let's break it down into steps. 1. Data collection. First, a large corpus of text data is collected. This data needs to be diverse and representative of the language the model will be generating. 2. Data pre-processing. The text data is cleaned and tokenized. Tokenization involves breaking down the text into smaller units, like words or subwords. 3. Training. The model is trained on this processed data. During training, the model is provided with sequences of tokens and learns to predict the next token in the sequence. The correct next token is provided during training, which is why it's called supervised learning. 4. Fine-tuning. After initial training, the model can be fine-tuned on specific datasets for particular tasks, such as answering questions or generating code. One of the key benefits of using supervised learning in LLMs is their ability to generalize from the training data to generate new unseen text. Let's look at a practical example. Example, chatbot interaction. Imagine you're interacting with a chatbot powered by an LLM. You might ask, "What's the weather like today?" The model uses its training on vast amounts of text data to understand your question and generate a relevant response, such as, "Today's weather is sunny with a high of 75 degrees. This ability to generate human-like responses is a direct result of the supervised learning process. In summary, supervised learning is critical for training generative AI and LLMs. By learning from vast amounts of labeled data, these models can generate coherent, contextually appropriate text, making them incredibly powerful tools in various applications like chatbots, content creation, and more. To wrap up, supervised learning is a cornerstone of machine learning, enabling models to learn from labeled data and make accurate predictions. It's used in everything from spam detection to medical diagnosis, and it's essential for training powerful generative AI models like GPT-4. If you found this video helpful, give it a thumbs up, and don't forget to subscribe to AI Foundation Learning for more tutorials and insights into the world of AI and machine learning. Thanks for watching, and see you next time.